1, 2, 3.
Good morning, teacher Lam and teacher Ob.
Good morning, students. Welcome.
Good morning, guys.
Okay. Before we start, let's first give teacher quickly an opportunity to do a short warm-up with us. Teacher, your mic is muted.
Left hand and right hand like this. And then this is 1. And the right hand, you have to point like this, 1. And then we're gonna switch 2. And then you have to point like this. And then 3, 4, 5, 6, 7, 8, 9, 10. Okay. Do you got it? Yes. Okay.
Yeah.
Okay. All right. Here we go. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Good job, everyone. Thank
So
you.
a little bit fast there. A little bit fast. Okay, that one we'll have to practice a couple of times, maybe before we get it 100%. But welcome back, guys, to another science class. In the previous lesson, I talked about our unit test that we were supposed to do. So if you have not done that, please complete the unit test on page 182 and 183. Okay. And then we moved on to unit 6, weather, sky, and the stars. So we're going to do a lot of interesting things, but currently we're first busy with weather. First looking at the weather before we carry on with the other parts. So just to recap for what we did last time, I have this short little voice bubble at the bottom. So let's quickly read this just to refresh our minds. Okay. So when air pressure increases, the water level will increase. When air pressure decreases, the water level will decrease. So what does that mean again? So what we looked at is if we go high above sea level, the water becomes more thin. There is less particles in the water, in the air, and it's also more difficult to breathe. The closer we go to the ocean, the more particles there are in the air, and also the more dense or heavier the air is, and that provides us with more oxygen. Okay. So when you go to a high place, for example, the top of a hill or in an aeroplane, you may feel a pressure in your ears. This is because the air pressure outside of your body is lower than the air pressure inside your body. The air pressure inside your body presses against the inside of your ears. So that's why when you go to very high places, you feel a funny feeling in your ears. So how do we usually fix that? We can either move our jaw to make your ears pop, or you can close your nose and then blow on your nose, put some pressure like this, and it will expand your ears because the pressure from outside is pushing your eardrums to the inside. Okay, so we can release this pressure by swallowing or chewing on something. So chewing on something is to move our jaw. This makes the air pressure on the outside of the body and the outside of the body equal and eases any discomfort you may feel. Okay. So that's just a little bit about air pressure. Why did we do this to start off? because this leads into our next part, which is going to be humidity. And Thailand is a country that has a lot of humidity, meaning sometimes it's not that hot, but because there's so much water in the air, we still constantly sweat. So you can see this boy here, he's like, I'm baking like a toasted cheese. It's so hot here. So humidity also increases the temperature your body feels. So if it's 35 degrees outside with high humidity, for your body, it might feel like 40 degrees. So it might be very hot. And that's something we are going to experience in the next couple of months when it starts getting hotter and hotter. Okay. So air humidity, something that we have a lot of in Thailand. So air pressure will decrease by about 1 millimeter of mercury for every 11 meters we go up from sea level. So sea level meaning when you are standing on the beach and you are next to the ocean, we are at sea level. So they say that air pressure will decrease about 1 millimeter of mercury for every 11 meters we go above sea level. So mercury is a type of metal that they use to determine air pressure and also determine how high are we above sea level. So if we have a mercury in a small tube and we lift it higher and higher, the mercury will change each level depending on if we are going up or down. So for humidity, I want us all to read together. So I will read the first part, then I will read this part here, then you guys must read it back to me. And then we do the same for the dry air. So let's start with humidity. Air contains water vapor, which is water in the form of a gas. This water vapor evaporates from liquid water sources such as oceans, lakes, rivers, and canals. Humidity is the amount of water vapor in the air. Warm air can hold more water vapor than cool air. Okay, so let me read the first part over here, and then you guys must read after me. Humid air contains a lot of water vapor, and the characteristics of humid air include wet clothes dry slowly, sweat evaporates slowly from our body, making us feel uncomfortable, and water evaporates slowly from water sources. Okay, so now I would like you guys to read to me. Are you guys ready? Are you steady? Let's see, are we ready? Yes, I hope so. Jasmine's ready, thank you very much. Okay, so you guys can start reading from humid air. Okay, you can start reading now.
Humid air contains a lot of
water.
Vapor.
Vapor.
Excellent. And then characteristics.
Characteristic of
humid air
include wet clothes dry slowly,
Sweat evaporates.
sweat evaporates slowly
from
the
our
body, making us feel uncomfortable.
water
Evaporates
Water evaporates slowly from water source.
Excellent, excellent. So currently in Thailand, the humidity is not that high, but it is also not low. It is in the middle. It's going to go higher also usually in the rainy season. Why? Because when we have a lot of clouds that are forming, we will have a lot of water vapor. And the clouds bring rain, but also brings a lot of humidity. So we'll look at clouds a little bit later. Okay, so let's quickly go through the dry air part. So dry air contains little water vapor. Characteristics of dry air include wet clothes dry quickly. Sweat evaporates quickly, so we feel cool and comfortable. And water evaporates quickly from water sources. Now, this makes sense because if the air is dry, the water will evaporate faster from lakes, dams, rivers, and the ocean. And when more water evaporates faster, clouds also start forming faster. So when the clouds then form, the air becomes moist and it starts to rain. Okay, so I want you guys to read dry air for me. Are you ready? Okay, not Leon's not ready. Okay, let's see. You guys can start now.
Dry air
This contains
contain little water
vapor.
vapor. Characteristic of dry air includes wet, cold, dry quickly.
Sweat evaporates. Okay, please listen carefully. Sweat evaporates quickly.
Sweat evaporates quickly, so we feel cool and comfortable. Water evaporates quickly from water source.
Excellent, excellent. Much better there. Water evaporates quickly from water sources. So humidity is something that we need in order to bring rain. So if we don't have any changes in humidity, we will not have warm and cool air that can form high and low pressure systems, which can bring rain. Okay, so let's quickly read the voice bubbles at the bottom here and see what they are trying to tell us. So air that cannot hold any more water vapor is said to be saturated. Now, saturated actually is also a different word for full. If there's no more space, the space is saturated. Okay, quite a big English word there. But what that means is, if we have 100% humidity, it is impossible for us to cool down. And what can happen is you can overheat and maybe even become very sick from overheating, or you can actually also die. So it's very seldom and very few times that you will find that there is 100% humidity, because that means that the air cannot hold any more water. So you cannot sweat anymore because there's no space for sweat to form in the air. So usually humidity is always less than 100 because you cannot live if humidity is more than 100 or at 100. Okay, and the next voice bubble, the amount of water vapor that can absorb is different in areas with different temperatures. If the temperature is high, the air can absorb more water. If the temperature is low, the air can absorb less water. Why do you think that is the case? If it's warm air, it can hold more water, and cool air holds less water. Why do you think that is the case? Well, I can tell you now that cold air means that the water is also cooler. So it is a less chance to form water vapor. If you think about a kettle, if you want to make a cup of tea or a cup of coffee, you put the kettle on and you start it. And after a while, the water gets warm and there's steam coming from the kettle. Is that steam cold or hot? Who can tell me? If you boil a kettle and the steam coming from the kettle, is it warm or hot? Warm or cold? Who can tell me? Warm. Yes, it's very warm. So that means that there is a lot of steam that can form when the water is warm. So there can be more water in air that is also warmer, because the warm air keeps more water because the water doesn't cool down and forms a liquid again. So that's humidity is quite interesting. And also, if you travel around Thailand, certain places have different humidities. And if you go across the world and you travel to different countries across Asia or different countries across the world, you will find different temperatures, different humidities, and all these different types of environments. And that's why if you look at Europe, sometimes it's very cold. So people wear these very big jackets and they wear these hats that cover their ears and make them warm, and very big boots on their feet that are nice and fuzzy so that they can be warm, because temperatures can drop to -20 in some places in the world. So -20 degrees is very cold. The coldest I have seen in Phetchabun is 7 degrees, and that was really cold. But at 0 is freezing, and that's a whole different temperature. Okay, so let's look at the last part here before we move on. So relative humidity is a unit used to measure how wet or dry the air is at any given temperature. It compares the actual amount of water vapor in a given volume of air to the amount that could be present in the air was saturated at the same temperature. Now, if the relative humidity is 100%, then the air is saturated. So this is just a lot of information explaining what relative humidity is. But for me to explain it easier, I would say that relative humidity is the amount of water vapor in the air that we measure. So that's a way we can tell what amount of water vapor in the air is, by using relative humidity. So at 100%, it means no more water can be in the air. The air is saturated. And also at that point, it is impossible to sweat. and to cool down. So your body can overheat very easily. Okay, now let's look at some ways of how do we test humidity and some of the instruments that we can use in science. So, if the relative humidity is 50%, then the air contains half the water vapor required to be saturated. And the instrument used to measure relative humidity is called a hygrometer. We have to practice this one. Very interesting English word. So I want us to practice this word all together. Okay. So all together with me, say hygrometer. All of us all together here. Hygrometer.
Hygrometer.
Now, what do we use the hygrometer for? Who can tell me? What do we use the hygrometer for? We use it to measure what?
Humidity.
Relative humidity. Altogether, relative humidity.
Relative humidity.
Excellent, excellent. So we use the hygrometer to measure relative humidity. But there are also different kinds of hygrometers. For example, the hair hygrometer and psychrometers, also known as wet and dry bulb thermometers. So those are different types, but the only important one for me is that we know what a hygrometer is for. It's to measure the humidity. Okay. Next part. Next part, they want us to look at how do we use the psychometer to measure humidity. So I'm going to refer back to the picture. So this is the, let me zoom in here so we can see a little bit better. This is the psychrometer. So for this one, we have a dry side and we have a wet side. So we're going to see now, how do we use an instrument like this? If we want to find out how much air, water vapor is in the air, very important that we understand why we use these instruments. Because science is a study of different things. And some of us maybe one day want to become scientists, or maybe we want to work at the weather station. Then it's important for us to understand why we use these types of materials and instruments. Okay, let's zoom in a little bit here. Using a psychrometer to measure relative humidity. Please listen carefully. This will be on our final test. So it is important to listen carefully. Okay. So using a psychrometer to measure relative humidity. So if a lot of water from the wet cotton ball that covers the bulb evaporates, the temperature of the wet bulb thermometer will decrease more than the dry bulb thermometer. So let's have a look at it. So they have a cotton at the bottom here of the wet meter. Why do they have a cotton there? Because they want to try two different methods. The first one is the normal dry thermometer. And the next one they do with the wet one, where they take a piece of cotton and wet it in this container at the bottom here. So what does that do? They say here that if the temperature of the wet bulb thermometer will decrease more than the dry bulb thermometer, when a lot of water from the cotton evaporates. So if the cotton becomes dry, then the meter will drop, the wet one, but the dry one will stay high. This means there's a lot of water evaporated. That is because the atmosphere can absorb a lot of water. Therefore, humidity is low. So, to give you another explanation again here, if we lose a lot of water, humidity is low. If we lose a lot of water, humidity is low because not a lot of water vapor is in the air. But if we lose very little water, humidity is high because there is a lot of water vapor already in the air, so we won't have enough space for a lot more water to enter. So I want us to read these two sentences to make sure we understand them. So on the right hand side here we say lose a lot of water equals humidity is low. Please read that to me. Lose a lot of water equals humidity is low.
Lose a lot of water equals humidity is low.
One more time.
Lose a lot of water equals humidity is low.
Excellent. And the next one is lose very little water equals humidity is high.
Lose very little water
equal humidity is high.
Excellent. One more time, please.
Lose very
little
little water equal humidity is high.
Excellent. Well done. Thank you very much. So that is just the basics of humidity and how we calculate humidity. So they talk about an example here of how to measure with the psychometer. So let's quickly just spend a few minutes to try and understand how do we measure using the psychometer. But we're only going to look at the example part for the last little bit of our lesson for today. So we're going to look at this part here. I'll quickly first read the top part just quickly, then we follow the example. So using a psychrometer to measure relative humidity. Number one, find the difference between the temperature measured by a dry thermometer and a wet thermometer. 2, find the relative humidity by finding the crossover point between the temperatures of the dry and the value calculated in step 1. Okay, so example. Using the psychrometer to measure relative humidity at the playground. So if you're at the playground or you're at school, these are the type of things we can measure. The temperature measured by dry thermometer equals 29. So the dry one equals 29. And the relative humidity can be found from the table as follows. So we look at the table just now. Number 2, the temperature measured by the dry bulb is 32. The temperature measured by the wet one is 29. The difference in the temperature is 3. So let's look at our table we have here. So you can use the table to find the crossover point. So they say our change. So this is the change between dry and wet. Dry versus wet. So we had a temperature change of 3. And the temperature of the dry bulb on top here, so this is the one for the dry bulb, was 32. So when we follow this table, we can see that our humidity is at 80%. Very, very interesting type of table we have here. So we can see, and I can show you another example. For instance, we can have a dry bulb. I'll put a D for dry. D for dry at 30. And W is wet. And we can take the degrees. Let me just sweep 30 degrees. 30 degrees and 26 degrees. Where can I put this to make it easier to see? I'll put it at the bottom here. Make it black. So now we have to calculate. How will we calculate? First, find the difference. The difference, D minus W. 30 minus 26 equals. What is 30 minus 26?
4.
4, excellent. Our change is 4. So then we go here to the change chart and we see we have a 4. And what is the temperature of the dry humidity? Is 30 degrees. So then we go over here. And then we can draw our line from here to here and here. So then we can see our humidity equals 73%. So that is just a couple of ways of how we test humidity. So if you work at a weather station, you will work with these types of charts and information. So science has a lot of different things we can do. Okay. But that is all that we're going to do today in science. If you guys want to see who can beat the teacher, now is your opportunity. Yesterday, we only had 3 students to beat me. Let's see if we can make it 5 today to beat teacher. Okay. So let's make sure we get ready. Always make sure we do our warm-ups so we can have the best opportunity to win. Are we ready? Let's go, let's go. And 1, 2, 3, shoot. Oh, is teacher unwinnable today again? Yay! Everyone draw except for Leon. Unlucky Leon. Maybe in the next class.
I got paper.
You got paper. Oh, unlucky Tantan. You and Leon unfortunately did not make it today. So no one teacher. That's beautiful. Yes. Maybe in the next class you guys can beat me. Okay, I'll give you guys about 20 minutes to take a break, get some water, nice, and stay nice and hydrated, and then we'll do some occupation. So see you now. Bye bye.
拜拜。